These new vehicles, including the more affordable models, will combine elements of Tesla's next-generation platform with proven aspects of the current lineup. The best part? They can roll right off the same production lines already building today's Teslas. That gives the Model 2 a real shot at affordability. No waiting for a brand new factory to be built. But Elon Musk's vision goes beyond just a low sticker price. The Model 2 is designed for long-term savings and peace of mind, with a sealed rust-resistant underbody, rugged unpainted cladding to handle everyday scuffs, bolt-on crash pods for quick low-cost fixes, plug-in 48V modules, and even a single serviceable HVAC block to keep time in the shop at a minimum. Before we dive into what makes the Model 2 a true game-changer for the masses, help Westech reach 219,695 subscribers. Hit that subscribe button and ring the bell so you never miss future updates. Now let's talk about one of the Model 2's smartest features, its three-piece body structure with bolt-on crash pods. Tesla designed the body around three main sections, front, middle, and rear. At the spots most prone to scrapes in tight city driving, sacrificial crash pods, or crush cans, are bolted on. These absorb the impact before it reaches the car's critical rails. This isn't just theory. Tesla already uses a version of this modular setup on the Model 3. With defined torque specs, it turns vulnerable areas into remove and replace assemblies instead of needing expensive frame repairs. Here's how it works. In a low-speed parking impact, most of the energy gets absorbed by the crash pod, since the rails and load-bearing structure remain untouched. A technician can quickly remove the damaged module and bolt in a new one following Tesla's published torque values. For example, Model 3 service docks specify 16 Newton-meters for bolts linking the carrier to the crash can and 75 Newton-meters for bolts attaching the bumper beam. That's a standardized, repeatable repair process, meaning less workshop time, lower costs, and less chance of hidden damage spreading deeper. The result shows up in your repair bill. Even light taps today can cost $850 to over $6,000 if the radiator or cooling system gets hit. That's why many owners can't drive home after what looked like a minor bump. With the Model 2's bolt-on crash pods handling the deformation, the chance of hitting a radiator or fan is way lower and your bill stays capped. The bigger picture? Insurance. Premiums are calculated on expected repair costs, and EVs often get totaled after damage that doesn't look catastrophic just because repairs are so expensive. By making everyday scrapes cheaper and faster to fix, Tesla Model 2 gives insurers a reason to keep premiums stable. That means owners feel the financial relief not just on day one, but in year 2, year 3, and beyond. It's a closed loop of benefits. Bolt-on crash pods make repairs simpler. Simpler repairs mean lower cost and less downtime. Lower costs stabilize premiums. Lower lifetime cost makes ownership easier. That's what makes the Model 2 not just affordable to buy, but affordable to keep. Truly a game changer for the masses. And let me ask you this. If a minor fender bender became a quick bolt-on swap instead of an $856,000 nightmare, would that convince you to buy? Drop Model 2 in the comments if your answer is yes. Oh, and here's another smart detail. The exterior. Tesla mixes painted steel for the main body with unpainted polymer cladding on the lower bumpers, rockers, and wheel arches. The top half stays sleek and stylish, while the lower half is built to shrug off scratches and scrapes without needing paint. Practical, cost-effective, and tough. Exactly what the Model 2 promises. These are the areas that most often scrape against curbs, brush other cars, or pick up stone chips, so Tesla wraps them in a material that doesn't show damage easily. By separating these scuff-prone zones with durable plastic, Small scratches stay less noticeable, and primer or bare metal never peeks through like it would on a painted steel panel. This cladding is usually an engineered plastic such as PP or TPO with UV stabilizers, and since the texture is molded directly, no top coat paint is needed. The advantages are obvious. Light curb rubs or stone strikes blend into the textured surface, dirt doesn't cling as much, and cleaning is simple. Painted sections above are also less likely to chip at the edges, lowering long-term rust risk, especially in areas with heavy road salt or gravel. Repairs are straightforward. If a cladding piece cracks or dents, a technician unclips and unscrews it, then fits a new one by part number. No sanding, no color matching, no repainting, and no blending into adjacent panels. Downtime shrinks and costs drop. By contrast, a painted steel panel often needs sanding, primer, base coat, clear coat, and sometimes blending into the next panel just to hide a small scratch. With the Tesla Model 2, high abuse zones shift to plastic cladding, eliminating much of that hassle. These little details add up. Grocery runs, tight garages, curbside parking, even automatic car washes, daily scuffs aren't a big deal anymore. After 3 to 5 years, the Model 2 is likely to look fresher, require less bodywork, lower exterior maintenance bills, and hold value better at resale. It's a small design decision that makes everyday life easier for a wide range of owners. Now let's move to another smart feature: the flat sealed battery floor with bottom access service hatches. The Model 2's underbody uses a flat battery floor combined with aero-style shields that seal the underside but still include hatches for inspections and service. On the Model 3, for example, the rear aero shield is held with 11 bolts torqued to 5 Newton meters, all removed from underneath while on a lift. That shows Tesla already supports underfloor access, and now the Model 2 carries it forward, making service quick, tidy, and standardized. A sealed underside also blocks dust, mud, and road salt from reaching wiring and connectors. EV battery packs are usually rated IP67, which means dust-tight and resistant to 30 minutes of immersion up to 1 meter. Combined with belly shields, this provides extra protection against puddles, splashes, and underbody washes. With less moisture intrusion, connector oxidation and nuisance faults are far less likely. For owners in snowy regions, coastal towns, or job sites, the Model 2's underbody stays cleaner and tougher. Maintenance is simplified too. Closed trays and access hatches let technicians replace parts from below without touching interior trim. If a shield is damaged or missing, the repair is a straightforward manual guided swap. Thanks to the flat floor and standardized access points, most jobs involving harnesses, hoses, connectors, or shields can be completed directly on a lift, cutting downtime and labor, which keeps maintenance predictable. Finally, Tesla's structural design brings even more gains. An integrated structural battery pack can reduce mass by about 10%, increase range by up to 14%, and eliminate roughly 370 separate parts. By making the battery a stiff, load-bearing piece of the structure, Tesla achieves cleaner routing for hoses and wiring, fewer joints, and a drier, cleaner underside. The result: lower oxidation risk, less maintenance stress, and more efficiency all around. Fewer minor faults mean fewer shop visits. And when service is actually required, bottom access speeds up the job. Put together, the flat-sealed battery floor with its service hatches helps keep Tesla Model 2 inexpensive to own throughout its life. Drop a Tesla wins in the comments if you believe a sealed, serviceable underbody works better than the usual open undercarriage when dealing with mud, salt, and shop time. Now let's look at the 48V power spine with standardized quick-swap connectors. Tesla Model 2 is built around a 48V electrical backbone that runs the full length of the car, powering seats, fans, pumps, and control units. The logic is simple. Power equals voltage times current. Keep the power constant, raise the voltage from 12V to 48V, and the current drops to about 1/4. For example, a 960W load that would normally demand nearly 80 amps at 12V only needs around 20 amps at 48V. Since wiring losses grow with the square of current, cutting current slashes heat and wasted energy. This lets Tesla Model 2 use slimmer wires with less copper, smaller connectors, and cleaner routing, all reducing weight and cost while boosting durability. In practice, Tesla organizes the low-voltage system around this 48V backbone, with short branches running to each device. At the ends of those branches, waterproof standardized connectors make assembly fast and service even faster. If a device still needs 12V, it gets it from a local 48 to 12V DC-DC module mounted close to the load. That short run means less voltage drop and less heat, so lights, fans, and actuators behave more consistently under heavy use. Add in electronic fuses and current sensors that trip instantly and log fault data, and you've got a system that makes troubleshooting far easier without ripping the car apart. Here's where it really pays off. Service. If a coolant pump, cabin fan, or small controller fails, a technician disconnects power, unplugs the 48V connector, and swaps the module. No chasing wires through meters of harness and no tearing apart the dashboard. Many of these repairs can even be done by Tesla's mobile service team in a driveway or parking lot in just 30-60 minutes, including diagnostics, replacement, and safety checks. Faster, cleaner service means less downtime and fewer risks of extra damage from repeated disassembly. Compared to traditional 12V cars with heavy wiring harnesses and countless joints, the 48V design cuts complexity, reduces failure points, and speeds fault isolation. Lower current also keeps connectors cooler and slows oxidation over time, so those mysterious low-voltage electrical gremlins become far less common. Put it all together, and Tesla's 48V backbone with plug-and-play modules means fewer shop visits, shorter downtime, lighter bills, and more predictable ownership costs. That mix of clever engineering and real-world convenience is exactly what makes the Model 2 a game-changer for mass-market buyers. And Tesla doesn't stop there. Next is the all-in-one 4-function HVAC unit. The Model 2's front-mounted HVAC system combines 4 jobs in one package: cooling the cabin, heating the cabin with a heat pump, dehumidifying the air, and managing battery temperature. The setup builds on Tesla's octovalve concept, using a multi-port manifold to direct refrigerant and coolant, so heat can shift smoothly between the cabin, the drive unit, and the battery pack. By packaging everything in one location, hose runs get shorter, joints are reduced, refrigerant volume is cut, and routine service gets easier. Fewer joints also mean fewer potential leaks, a lighter system, and better control over noise and vibration at the front of the car. The result? A more efficient and more durable setup for daily driving. Efficiency is the real headline. In typical use, a heat pump delivers a coefficient of performance around 3 to 4, while resistive heating stays near 1. In simple terms, Tesla Model 2 can heat the cabin in cold weather using far less energy, making it not just smarter, but also more economical in daily life. Real-world data from heat pump EVs shows they retain about 83% of their rated range in freezing conditions, compared to roughly 75% for vehicles without a heat pump. For owners, that means quicker cool-downs in summer, faster warm-ups in winter, and less range anxiety when the temperature drops. The integrated thermal block also brings better humidity control and clearer windows. When the driver selects defog or dehumidify, the manifold routes refrigerant so the evaporator lowers the air's dew point before it reaches the vents. That drier airflow keeps glass clear on rainy days, reduces musty odors, and helps carpets and surfaces dry faster after passengers track in snow or rain. Because the Model 2 relies on one central thermal hub, software can intelligently balance comfort and performance. During a fast charge, the system diverts extra capacity to battery cooling to sustain charge speed. On a cold start, it can recycle waste heat from the drive unit to warm the cabin quickly. And when service is needed, the layout proves its worth. Instead of long hoses and dozens of valves, the Model 2 uses a cast manifold with standardized ports. A technician can pop open the cover, check for leaks, isolate a circuit, pull vacuum, and replace a sub-assembly far faster than with a traditional split HVAC system. If a sensor, valve, or short hose section fails, the streamlined design shortens fault finding and speeds part replacement. The chain of cause and effect is easy to follow. Consolidation means shorter plumbing and fewer joints. Fewer joints mean fewer leaks and less refrigerant handling. A more efficient heat pump cuts energy use and protects range in both hot and cold weather. And when service is necessary, the single block design makes for quick swaps. The outcome is a Tesla Model 2 that heats and cools faster, needs less finicky maintenance, and saves owners money over the years. Tesla's affordability strategy isn't just about the sticker price. It extends into ownership. Bolt-on crash pods, durable lower cladding, a flat-sealed underbody with service hatches, a 48V backbone with plug-in modules, and a single serviceable HVAC block all work together to cut downtime, reduce random repair bills, and keep miles steady without stress. If Tesla stays on track for 2026, that's the year when an EV truly goes mainstream. Tap subscribe and ring the bell so you don't miss the next shocking updates on Tesla's game-changing innovations.